Have you ever tried to plug a device into a socket only to realize the plug doesn't fit? You've got power on one side, a device on the other, but they just can't talk to each other. That's frustrating, right? Well, in software, the data adapter design pattern exists to solve this exact problem, but with data. In software systems, especially large ones, different components are often built at different times by different teams, and sometimes even in different eras. One system might output data in XML, another expects JSON, one might store user info with field names like first name, while another system insists on given name. Without an adapter, these systems can't work together smoothly, and that's where the adapter steps in. The data adapter design pattern is a structural pattern. It acts like a middleman between incompatible interfaces. Think of it as a universal translator. It takes data in one format, transforms it, and outputs it in a way that another system can understand. Picture this. You're traveling abroad. You walk into a hotel, open your suitcase, and take out your laptop. But the wall socket looks completely different from the plug you brought. Do you give up? No. You grab a travel adapter. That little device doesn't change the electricity itself. It just reshapes the plug so it fits. The laptop gets the power it needs, and the wall keeps delivering electricity the way it always has. That's exactly how a data adapter works in code. Let's say you have an application that consumes customer data from an API, but the API returns fields like fname and lname, while your app expects first name and last name. Instead of rewriting the app or forcing the API team to change, you create an adapter class. That class receives the raw API data, transforms the fields, and delivers it in the format your app already understands. Neither side needs to change. The adapter does the heavy lifting. So, what's the big win? First, reusability. You don't need to rewrite old systems, you adapt them. Second, flexibility. If you ever change your data provider, you only rewrite the adapter, not your entire app. And third, clean architecture. Your core logic doesn't get cluttered with messy conversion code. Instead, it stays focused on what it does best. Now, like any pattern, there are trade-offs. Overusing adapters can add complexity. If every little mismatch requires an adapter, your codebase may start looking like a tangled mess of converters. That's why it's best used when you genuinely need to bridge two independent systems, especially when neither can easily change its format. So, the data adapter design pattern is all about making the incompatible compatible. It's the travel adapter for your software systems. It doesn't reinvent the wheel, it just makes sure the wheel can fit on the car you already have. The next time you find two systems that don't speak the same data language, don't panic. Just remember, all you might need is an adapter.